Thank you very much for the introduction. Ladies and gentlemen, as we navigate through an era of an unprecedented global change, we find ourselves confronted with a stark reality: the alarming decline of global biodiversity. Around 54% of the wildlife population density is expected to be lost in the next 80 years if we do not act. And depending on the actions that we make, we can even bend the curve of biodiversity loss. But if you focus on this picture, you will see that all the icons depict big plants or mammals, birds, animals, almost suggesting that Earth's biodiversity is dominated by them, by plants and animals. But as you can imagine, due to today's topic, that's far from reality. And it's necessary and crucial to recognize that biodiversity is not just a matter of charismatic species in beautiful rainforests or in majestic savannas, but actually, it mostly is microscopic and resides beneath our feet, within the soil. Did you know that a staggering 60% of the total biodiversity on Earth is estimated to live in soils? Yes, you heard that right. 60% of the total biodiversity on Earth is estimated to reside in soils. But not only that, only 1% of it is estimated to be known. Yes, you also heard that right. Only 1% of the soil biodiversity on Earth, on soil, is known. I don't know if you can see this. It's a jar containing soil, little amount of soil, probably insignificant, especially from the back of the room that you probably cannot even see it. Well, in this jar, we might contain millions of bacteria, meters of fungi hyphae, or thousands of tiny amoebae. But the relentless march of the human-driven global changes, such as drought, has taken its toll in this hidden ecosystem. And it is said that approximately 2.8 tons of soil are lost annually per hectare, according to the European Soil Data Center. But why are all these microorganisms important, you might ask? Well, a part of being the majority of the soil biodiversity and the majority of the biodiversity in the world, they provide us with ecosystem services that are crucial for our life. They can generate compounds that are necessary for the creation of vaccines. They help capturing CO2 in the ecosystems. But today I'm going to focus on their function, helping plant growth. Bacteria and fungi, normally they decompose the organic matter. But they are a bit selfish, and they do not completely share those nutrients with the plants, and these nutrients are necessary for plant growth. And here is where predators enter in this narrative. And now we are not talking about sharks or lions. These predators are tiny, they are microscopic. This is the hyper-diverse world of protists and nematodes. Protists are all the eukaryotes that are not fungi, animals, or plants, and I can tell you that they are the majority of the eukaryotes. And nematodes are the most abundant animal in the world. Well, they predate, for instance, protists, they can predate on what in comparison are much bigger organisms, and in some of them, they do it by pack hunting, as lions do. If you don't believe me, you can see this video. In this video, you see this round organism, that's Cryptodiflugia operculata, a protist that basically is hunting down what in comparison is a much bigger nematode, and they do it by pack hunting. They can also predate on harmful pathogens, but especially through predation, they release the nutrients selfishly stored by bacteria and fungi, and they make them accessible to plants. Additionally, through the predation, they can shape the microbiome in a way that it creates conditions conducive to plant growth. Our research delves into the profound impact that soil microbiome predators have on plant performance, especially in the face of global changes such as drought, fertilization, pathogens, big problems nowadays. Well, and the results actually are pretty interesting. Take, for instance, the first experiment with tomato. In here, we had pods with or without drought, and with or without pathogens. And in all of those treatments, we had an increasing diversity of soil microbiome predators. From 0 species, we increased the diversity until reaching 30 species of soil microbiome predators. And we found that an increasing diversity of these predators actually had a positive impact on plant growth when facing pathogens. However, not the entire picture was as beautiful. When facing drought, an increasing diversity of microbiome predators affected negatively the plants. This highlights the critical importance that global changes have on the relationship between soil biodiversity and plant health. In another of our experiments, this time with cannabis sativa and dealing with the fertilization problem, we created an experiment in which pots contained different levels of fertilization. From 0, we didn't add fertilization, to low, medium, or high fertilization treatments. And again, in all of those treatments, we added an increasing diversity of soil microbiome predators. Overall, we showed that just by adding these soil microbiome predators, the plant performance was impacted positively. But the most interesting result is the next one. Oh, sorry. From 0, we increased the diversity 0 to 6, 12, and 24 species. This is the results I was referring to. In the upper row, you can see the treatment with only fertilization. And in the bottom row, you can see fertilization and diversity of microbiome predators added. And what we can see is that by adding these predators to the low fertilization treatment, we can already achieve a biomass that is comparable than when we only use high fertilization treatments. This might open the door to future research and for the application of these microbiome predators to reduce the need for fertilization. In conclusion, microbiome predators, they have the potential to steer plant growth and production, especially in the face of global changes. However, biodiversity is not yet a one-for-all solution, and it really depends on the human-driven global changes. But let's not forget the bigger picture here. Soils host approximately 60% of the total biodiversity on Earth, and microbes, which is the majority of that diversity, is not just a resource for us to exploit. Yes, it can provide with services. Yes, the potential of application is certainly there, but actually, the significance goes far beyond human utility. Thank you very much.